The next part, the second part of this tutorial is related to Power Pivot. What is Power Pivot? It's basically the database inside the Excel worksheet. It's very efficient, allows you to work with lots of data, big amounts of data. Then for the analysis, one can use DAX expressions or data analysis expressions. We will look at them today. And what is also important, and we will check today, is that the data from many different sources and databases can be important inside this Power Pivot. As the basis for the tutorial, we'll use tutorial 3 Power Pivot draft workbook, so we can start it. And then to go to the Power Pivot interface itself, on the Power Pivot tab, we press Manage, which says go to the Power Pivot window. So obviously now Power Pivot window will open. The data model in this file, it's not completely empty. It already has one table. That's why when you open it, it has one tab, calendar. So we will go through different tabs and functionality of Power Pivot today. But basically, when you open it, it looks really similar to the Excel. It has different tabs, currently only one. And this tab, it's related not to the worksheet, but to the table in the database. So on the Home tab, I can press Diagram View. And I will see that now in this Power Pivot database, we have only one table. We will import now more data to the Power Pivot of this workbook. We will import it in several different ways. So let's go to the exercise. All right, here is the exercise. We are asked to import data from audio store database, and then as a final product, we need to prepare this pivot table. So we import data from the database, implement DAX functions, and then the result should be the pivot table, which looks like this. This pivot table, it shows how sales of every salesperson change from year to year. For example, for Johnson, it increased by 15%, 15.5% in 2011. First step is to import data, and we import data first from the Access database, data about employee. Database is provided also in the files of this tutorial. It's called Audio Store. So to import data in the Power Pivot, on the Home tab in Power Pivot window, we choose Get External Data from Database and from Access. And in this dialog window, we need to specify from which database we would like to import the data. So database name, it's not only the name of the database, but the path to this database. We will browse to the database. You should know where you save the database. And we will choose this access file, which provided to you in Moodle, Audio Store access file. Choose it, press open. Then it's nice to test connection. Let's test the connection. Everything is all right. We press next. Here we have two options. We will test them both today, but now we choose the first option. We will use user interface, graphical interface to import the data. Again, next. This is the list of tables located in the database. We need only one table employee, so we can put the mark to the left of it. And furthermore, from all the employees, we need to import only the salespeople. It means that we will filter the data that we import. And to filter the data in this table, we choose the row related to the stable employee, and then press Preview Filter button. The dialog opened. From this table, we want to import only two columns. These are employee ID and last name, so first two columns. For that, I will press the most left mark to unselect all the columns and then explicitly select employee ID and last name. And next step, we don't want to import all the employees. We want to import employees with the title Sales Support Agent. So I can filter these columns, title. I don't need to select it to be an import, but I can filter which records will be imported. I deselect all and select Sales Support Agent and press OK. Now this is the data which I would like to import. Now I press OK, and now I can press Finish. It was imported successfully. I press Close, and now we will see that in Power Pivot, in this diagram view, we have a new column, a new table. This table is called employee, the same way as it was called in the source database. If I now in the Home tab press Data View, I will see that we have a new tab, employee, and this is the data. The data exactly what we asked to import. This was first type of import that we do for the database, and second one will be with the help of the SQL query. So we start in the same way. We go to From Database, From Access. We will choose the same database file, Audio Store. Next. But now instead of using graphical interface, we will specify the SQL query. This SQL query is already provided in slides. We don't need to write it. It's here. You can just copy it. What it does, it basically imports the invoice data from the database, or it selects the invoice data and then we'll import it. So we copy it to the SQL statement. That's validated. Everything is correct. We can press Finish. 412 rows were imported, close. And now we see that we have a new tab, a new table that is called query. Yeah, that is called query with the data that we needed. Query, it's not the descriptive name, so we need to rename this table, and it said that it should be called invoice. To rename the table, we can double click on its tab and then write here invoice and press enter. So we renamed the table, and that's how we imported the data from the external database. If we go back to the Excel worksheet itself, we see that it has information about the exact products which are in every invoice. So if I go to the invoice, there is no information about the products, about the sales amount in this invoice. And this information, it's provided to us in this case in the worksheet itself. And now we want to import and add this information as well to the Power Pivot. There are two ways which we'll have a look how to add this information. First, it's simply copy pasted. So I can select all this data in this range. So I can select one cell and then press Ctrl A to select the whole range. Then press Ctrl C to select the data. And then when I come back to the Power Pivot window, I see that this icon now is active paste. I will press this icon. It opens the new dialog box. It gives me the preview of the data which I will now paste, and I will call it this data. I guess it's written invoice items. I will call it invoice items. Use first row as column headers. That's correct, and I press OK. Now this data is added to the data model, so we will be able to use it later for the analysis. This was the first way how we can add the data from the worksheet. Another way is more advanced, and it has several benefits, or one benefit. According to this copy and paste way, if we now change anything in this data, it will not be updated in the Power Pivot itself, because we simply copied the data. There is no any kind of link between worksheet and this information in the Power Pivot. But we can add this data in a way that if we will change something on this worksheet, it will be also represented in the Power Pivot. For that, we add it as a linked table. So first step is to add or to specify this range as a table in Excel. For that, we choose any cell in the range, press Insert, and press Table. Table has headers, everything looks right. All the data was automatically selected, so we press OK. And now in the Table Design tab, Menu tab in Excel, we go to the table name and we will rename this table to something more descriptive. So we will name it TBL for table underscore and then invoice items. Same as it was before. So we added the table and now we want to add it to the data model, to the Power Pivot. To do that, we choose this table or any value in it. Then in the Power Pivot menu tab, we choose Add to Data Model. And now it adds the new table to the data model. And this table, it has the exact name as table in Excel, TBL invoice items. And now the advantage of that is if I change anything here, it will be also updated and changed in Power Pivot. So I can quite easily change the data in Power Pivot. This was the second way how we can add worksheet data to the Power Pivot. As for now, we imported all the necessary data that we need. We have invoice items, invoice, employee, and calendar. And the last step in establishing the data model that we need is to specify the relationships between the tables, the same as we do in the relational databases. To specify the relationships, we go to the diagram view in Power Pivot window. So on the Home tab, we press Diagram View. We see here all the tables that we included, even for invoice items, 2 times in 2 different ways. Now we know that employee ID, it's referenced in the invoice as a support rep ID. So we can establish relationship, and to establish this relation between these 2 tables, we drag employee ID field into the invoice table, into the support rep ID field. And now these 2 fields are defined as primary key and as 2 keys. And we see that support rep ID is a foreign key to the employee ID primary key in employee table. This is one-to-many relationship. Same we want to do for the invoice and invoice items. So invoice items, it has the foreign key invoice ID, which specifies to which invoices items are related. So I drag invoice ID from invoice to the invoice ID in invoice items. And the last thing that we want to establish a relationship between invoice table, invoice date, and date in the calendar. So I drag invoice date to date. This is the final version of our data model. Also in the solutions, I guess invoice items it's called in the singular, so let's rename it to invoice item so that all the formulas that we write later they're exactly correct. This is the final version of the data model. We can save it and close. And now why did we actually prepare this data model? One way to use it is pivot table. So on the new worksheet, I can insert pivot table. And now as a data source, I will choose not the range, but I will choose use this workbooks data model. It means that use data model in Power Pivot. I will press OK. And then we see that in the list of fields, instead of the fields, we see icons for the tables. So every icon is related to the specific table. And let's say that we would like now to calculate the total number of invoices for every employee. For that, I can choose from employee's last name as rows. And then I can choose invoice ID as values. And I don't want to sum all the invoice ID, I want to count them. So I choose the aggregation as we did before several times to count. And since these two tables, they are related to each other, you see that you get for every employee different number, because how Power Pivot does it, it counts only that invoice IDs which are related according to the relationships that we established to the employee Johnson, to the employee Peacock and Park. We can also do it through over the years. So if I will add from the calendar year as a column, we'll see the statistics per every year. And it will also work correct because we establish a relationship from invoice to the calendar table. So this is the way we can use Power Pivot information. But if I now come back to the initial task that we're asked to do, and we're asked to prepare the pivot table, which looks like that, we see that what we are asked to do, we need to calculate the changes of sales for every employee from year to year. And you might think that one way to do it is to use calculated field in the pivot table. Let's go to the calculated fields for pivot table. So pivot table analyze field item sets. First of all, this calculated field menu, it's grayed out. We cannot add calculated fields to the pivot tables that are based on the Power Pivot data. But even if we could, there is no any way you can use calculated fields to perform such kind of calculations, to find the sum for every year and then find how this sum changes. And to do that, we will use DAX formulas or DAX expressions. DAX expressions are really similar to the Excel formulas. Two main differences are that we write these formulas not in Excel worksheet, but in Power Pivot window and in Power Pivot data model. And secondly, as an argument, these formulas, they take not specific cells, but they take the whole columns or even tables. There are two types of them, calculated columns and DAX measures. We'll look at both of them because it's quite difficult to explain what is the difference before you really experiment with these formulas. There are operators for DAX expressions, which are often the same as for the Excel formulas, like plus, minus, multiplications, some concatenation to concatenate the text, and some comparison operators. Then there are logical operators to see if something is true or to see whether multiple things are true. We will not use them today, just for you to know. And what is the most important, that there are functions for DAX expressions. Some functions, they look visually almost exactly the same as Excel functions, like there is a sum function, max function, and so on. Some functions, they look slightly different. For example, sum x, it has x at the end, so the name is different. And then the arguments which it takes not some row or number of cells in an argument, it takes the table as an argument. And then the expression, it's column or some operations with the column. We'll use this function today and see what exactly it means. And there are other functions. We'll try several of them. As the first exercise, we will look on the calculated columns, first type of the DAX expressions. We are asked to do three things. First of all, to calculate total for each invoice, then calculate total sales for every employee, and then we are asked to use or try to use this total sales in the pivot table, because these are the steps to achieve our final aim. It's to find the growth rate of sales for every employee. I will make intentionally several errors, mistakes, to show you the differences between calculated columns, DAX expressions, and Excel formulas. So we start with calculated column. As I said, we don't write the DAX expressions in the Excel itself. We go to the Power Pivot window. So Power Pivot Manage. Let's now check how can we calculate the total for each invoice. When I go to the invoice table, I see that in the table itself, I don't have any information to calculate the total sales amount from this invoice. There is location, date, but I don't know how much money products in this invoice were sold. The exact sales amount, it can be found in the invoice item table, because in the item table, every record it's related to some invoice. Let's look at first two records. We see that these two records or first two invoice items, they are related to invoice with ID 1. It's here. Means that in that invoice with ID 1, two tracks were sold. We see it from the column track ID, because this company, it's audio stores, they sell tracks. The price of track with ID 2, whatever track it is something like €1, and of the track with ID 4 is also €1. But we see that now in the quantity column, the amount of tracks of each track which was sold in invoice with ID 1. And there were two tracks with ID 2 sold in invoice with ID 1. I'm not sure what the sense to purchase two same tracks, but as an example. And only one track was sold in invoice with ID 1. For starters, let's now calculate the total not for the whole invoice, so not for the whole invoice with ID 1, but let's calculate total per one item. So in other words, I want to calculate what was the total price of all tracks with ID 2 in invoice 1, and of track with ID 4 in invoice 1, and track with ID 6 in invoice 2, and so on. For that, I will add the calculated column and write there the DAX expression. You see here, you can add column. So not only the data which we imported to the Power Pivot can be used in our analysis, but we can add data by ourselves or calculate it on the run. That's how we use DAX expressions. I double click on add column and write here the name for this column. I will simply write total and press enter. And when I do it, the empty column will be added. There is no any kind of, if I check the cell, no any kind of calculation in the cells, and that's why the results are empty. Now, let's start to write down the DAX expression. I choose the cell. I can choose any cell. It's not important. And then in the same way in the Excel, in this formula input field, we see that there is already equal, which says that now we will write the formula. I will write my calculations. As the total for every track in every invoice, I use two columns to calculate it. Unit price and quantity. I want to multiply unit price by the quantity. So let's start writing unit price. When I start writing unit price, it provides me two suggestions. You see, first I can choose this suggestion, which is the column name in the square brackets. That's the so-called short reference to the column. Or I can choose this suggestion. And you see that here, in addition to the column name in the square brackets, I have also the table name. This is the full reference to the column, which specifies not only the column, but the location, the table of that column. In this example, it's enough to use the short reference. And why it's enough, I can double click on it. Why it's enough? Because then our pivot, it will understand that this column is related in the same table invoice item, in which I write DAX expression. And I want to multiply it by quantity. So I can open the square brackets, choose with my keyboard or with the mouse quantity. Then I can press double tap on it or press tab. That's my formula. You see, I didn't specify exactly for which row should I take these values and so on. It's quite important. And then I press enter to finish formula input and see the calculations. And we see that this formula, it populated to all the cells in the total column. So in every cell, I have the same formula. And basically, it's not important to, it's not possible in Power Pivot to specify different formula for different cells in the calculated column. It will be always the situation that in every cell here we have the same formula. But still we see that values of the results of calculations in every row, they are different. Why are they different? Because for every row, we take the values of columns that are specific for that row. So for this first row, unit price is 0.999 is taken or evaluated as 0.999, and quantity is evaluated to 2 because that's the quantity in the current row. If I go to this row number 7, here unit price will be the same, 0.99, but quantity will be different. It will be 3. So that's how we added total as a calculated column in the invoice item table. All right, so the next exercise is to calculate the total sales for each sales employee. Mechanics of this calculation are very similar to the total calculation of total for each invoice. If I go now to the employee table, I can add here a column which is called total sales as it's specified in the exercise. Now how actually we calculate the total for each employee. Let's go to the invoice table, and you see here there is a field called support rep ID. That is the field which basically references the salespeople. So for invoice with ID 1, the sale was done by employee with ID 5. For the second invoice with ID 2, the sale was done by sales employee with ID 4. So to calculate the sales for each employee, we just need to find the sum of total column in table invoice for all records that are related to that specific employee. For employee 5, for example, we need to calculate total for all the records where in the field support rep ID we have 5. Let's do it now then. We established in the previous task relationships between tables. That's why employee and invoice tables are related. Again, we want to find the sum, so it's sum x. Then as a table, we don't take the invoice table as a whole. We only take the records from the tables that are related to the current employee. So related table from table invoice, and we want to find the sum of column total. You see, it's almost the same formula as what we used for invoice and invoice item table. We got the solution and calculation. This calculation looks correct. We have the different number for every employee, and this number, it shows what are the total sales for the employee during the whole history of our company when we recorded the sales for this employee. The third task in this exercise is to use total sales for each employee in pivot table, and then also to use this total sales to show the sales of employee in each year. Let's go now to the pivot table, and if now I look at the list of fields which I can use in the employee table, I see that there is a new field, total sales, and this is this calculated field that we added. So now why we basically did it, because we can use it in our analysis in the calculation in the pivot table. First, I don't need these years and columns. I drop them back, and I add total sales and count of invoice ID. I also don't need. I add for every last name for every employee, I add total sales calculation and see values that I get. Of course, I get here exactly the same values as I get directly in the Power Pivot. Pivot table is just an interface to see the data which is stored in Power Pivot. All right, it works, but now I want to see total sales not for the whole history for every employee, but in every year. So I can take year from calendar and drop it to columns. First of all, I get here something like a relationship error when I do it. Relationships between tables may be needed, and it tells me, Excel tells me here that something is wrong. Also, I can see that something is wrong because for every year, for every employee, the number is the same. So somehow this number is different between the employees, but it's the same for every employee from year to year. And why it is like that? The reason that it is like that is because of the nature of calculated columns and something what is called context. What is context? Context is basically the filters and groupings that we use in the specific pivot table. So this pivot table that we built here, it has the context of employees and the context of time or years. Yes, so every cell or value cell in the pivot table, it should like filter the data according to the employee and according to the year, which are context in this pivot table. But the nature of calculated columns is that calculations in the calculated columns, they don't take into account this context at all. If I go back to our calculations, you see that I calculated this total sales for every employee, and that is what demonstrated in this table. But this calculated column, it doesn't take into account context that I will use in the pivot table. So whatever year or other filtering I will use, this value, it will always like stick to the employee. It's like a, first name. Whether I take 2010, 2011, first name of the employee will be always shown the same. And the same is this number. Any filters that I use in pivot table, they aren't taken into account. And that's why often you might see that people don't suggest to use calculated tables, because when it comes to the filtering in pivot table to the context, you might get results which are difficult to interpret. And this exercise, it was formulated in this way to show that calculated columns, the type of DAX expression calculated columns, they are not completely suitable for this kind of calculation. If we want to see the sales over the year, and our final task, if we come back to it, I think it was on the slide 36, our final ultimate task is to not only calculate the sales from year to year, but also the changes in sales, growth rate of sales. And therefore, for this calculation, we will use DAX measures. DAX measures, it looks pretty the same as calculated columns, but these measures, they are really taking context which is applied in pivot table, they take it into account. We are asked now to calculate three different measures. It's total sales for every employee, then total sales for 2009. It's not so necessary, but just for the demonstration how we can do it. And the growth of sales from 2009. We'll calculate here not the growth of sales from 2009, but growth of sales from 1 year to the previous year. Let's start from the total sales measure as one of the easier cases. We write measures not in a columns in Power Pivot, but we write measures and formulate them in a calculation area. So in this area here in the lower left corner. If you don't see this area, you can press calculation area in the home tab of Power Pivot window. So here you can turn on and off this area. Now to calculate the total sales, we will add this measure in the invoice table. And here we select any cell that we want. And in the formula area, let's first write the name of the measure, which is total sales. I will write measure to show definitely that it's a measure. Then we put a semicolon, no colon, we put colon and equal sign. Don't put here any kind of space and so on, because it will lead to the syntax errors. And now we write down how measure should be calculated. Since it's the measure, since it's measure and we have established relationships between all the tables, we don't need to specify take one value from related table, other not from related table. This all will be clear from the context that we provide in the pivot table. Therefore, to find the total sales, it's enough to write sum, and then sum of which column we calculate as the total sales. And it is the invoice total column. Total sales measure, right. And we press enter. This measure will be now added to the Power Pivot here, and we can use it in the pivot table. So I will go back to the pivot table, and I see that in the list of fields for the table invoice, I have here total sales measure now, and it has the small icon, which means basically the measure. and it shows the difference from the normal fields and from the calculated columns. I can now drag this total sales measure to values, and I see that this measure is calculated for every year and for every employee. It's different for every year and every employee. So we can see changes from year to year. And in addition to that, when I look at the grand total, and grand total, these are sales of all the sales for the specific employees in the entire history of the company, you see that these values, they correspond to the values that we calculated before as a calculation column. So what measure provides us? It lets us define by ourselves the context or the filtering when we make analysis in the pivot table. Next assignment, we are asked to calculate the total sales for 2009. So the main difference here is that we won't take this measure, which we calculated before, total sales measure, but we want to apply the filter or the context to it so that we get sales only to 2009. And measures, they allow us to, so to say, hard code the filter in the formulation of the measure. Let's see exactly how it looks like. I go back to the Power Pivot. I will create here the new measure, which is called total sales. Then colon and then equal. And what I want to do here, I want to take this total sales measure, which we calculated before, but I want to apply filter inside the measure definition. And this filter should say that take only that records which are related to year 2009. For this case, specifically when we want to formulate the context or filters inside the measure definition and hard code it there, we use calculate formula. Then here as an expression, I could again rewrite that calculate the sum of all the total column for all the records, but I can simply reference the measures that we did before. So I can write here total sales measure. So basically that's what we calculate inside it, the total sales. And now I want to say, since it's for 2009, that always filter of 2009 should be applied. It is the second argument. Filter 1, we can provide multiple filters. Since I established relationships between the table and table invoice, it's related to the year. What I want to the table calendar, what I want to say here is that take only that records that are related to year 2009 from the table calendar. For that, I write here the name of the column, year column in calendar, it's year, and then I say that it should be equal to 2009. Now I can close the bracket and press enter. So in this measure, I just hard coded that it should always make calculation for 2009. And let's now see how will it behave when we provide context for it in pivot table. I go back to the pivot table. I see that this measure appeared now here in the field list. It's called total sales 2009. And then let's drag it to the values so that we see total sales and total sales 2009. And on the first side, it looks quite weird. Let's, for example, look at the values of 2010. We see the total sales measure, it's 140. For the next year, total sales measure, it's 162. So it's the same as we did this calculation before. But this total sales 2009, it's always the same for whatever year context we provided. And if you think about it, basically it's correct. It just says that if you are asked in 2010 what were the total sales in 2009, that's what it shows you. The answer in 2010 would be 168. If you are asked the same question, total sales of 2009 and current year is 2011, still the answer will be 168. So that's how it should be interpreted, that in whatever year we are currently now are, the total sales of 2009, they are the same from year to year. And if I look at 2009 here, total sales measure and total sales 2009, they are the same. Why? Because in this year, if you are asked what are the total sales of 2009, they will be 168. So this kind of behavior, it's natural for, and that's how DAX measures should behave. It might be at the beginning difficult to interpret and understand it, but since we hard-coded the filter into the measure, it will not depend on the year. But if we apply, for example, for 2009, the employee context, this context, it changes the value. So when we apply context of employee for park, we see that in 2009, sales were 170. And for park, this value will be always the same from year to year because year is fixed, but other contexts and filters, they still work as it should, as they should. And the last step, we will not calculate the growth rate of sales from 2009. We'll calculate exactly what we need. And exactly what we need, it is the growth of sales from employee to employee. To calculate that, first, we need to define the measure. And this measure will be called total sales of previous year. It means that whatever context, or if we provide in pivot table in context the year, this measure should calculate the total sales, not for that year that we provide, but for the previous year. Let's see how it will look like. Now I will rename, we don't need this total sales 2009, it was only for demonstration. Let's name it previous year, so total sales previous year. And here as a calculate, we will still use total sales measure, but as a year, it was hard-coded 2009. What I want to say here, it's filter not by 2009, but filter by the same dates, but from the previous year. And to do that, you have the formula basically for that, or the function. This function, it is called same period last year. Same period last year, and then we specify from where the dates should be taken. And the dates are taken from the related calendar table. So it's calendar date. So what does basically say? It says take the context that you are provided, and we will provide in pivot table the year context, and take the same dates but from the previous year, and then calculate the total measures for that previous year date. Let's again press enter, and now I will go back to the pivot table and see how this thing behaves. So while it's, yes, now it's saved. Pivot table, yes, it automatically changed or redefined the previous measure, which we had total sales 2009, and then it substituted it now with total sales previous year. So for 2009, we don't have any values, and the reason for that is that we don't have information about total sales in 2008. But let's see at the total sales at the data and report for 2010. Total sales, of course, they didn't change, but total sales previous year in 2010, they are different from total sales measure. And if we look at these values, they're exactly the same as total sales measure for 2009. And why it is like that, it's easy to understand and interpret, because in 2010, total sales for the previous year, these are basically the total sales of 2009. So that's how this measure works in pivot table when we provide the year context, and still other contexts like sales employee, it will work. And now the last element which is left, it's to create a measure which we will call sales growth. And this measure, it will divide total, it will basically divide total sales measure by the total sales previous year measure, so that we find how much sales increase from year to year, and we will compare current sales with the sales of the previous year. I go back to the Power Pivot, I create the new measure, sales growth, colon, equal, and then we don't need to write everything from scratch. Again, we can use reference the measures that we defined before. So it's total sales measure divided by total sales previous year, and we want to find the growth rate. That's why we need to subtract 1 from it. And let's press enter, and now we can come back to the pivot table. I will bring back pivot table field list, and here we don't need any of these measures except sales growth. So I will untick them and then drop sales growth here. In 2009, we have an error because sales in 2008, they are 0. We know nothing about them. That's why we cannot divide by 0. And here we get an error. You can filter by year or something to get rid of this column. Then I would like to have sales growth represented as %. That's why I go back to number format of the field. Number format will be percentage. I don't know why it shows me park. So decimal places 0. And okay, yes. And now we see the growth rate. It means that sales of Johnson from 2010 in 2010 they drops by 16% in comparison to 2009, and in 2011 they increased by 15% in comparison to 2010. And that was our final aim, where we used DAX measures, and you can see that the sales growth measure, it would be quite difficult to attain these numbers or get the same result using other techniques in pivot tables or in Excel. But as a measure, it's very suitable to calculate more or less complicated things in Excel Power Pivot. So you have a solution here, and it was basically everything about Power Pivot for today. So we look today at the pivot tables and Power Pivot formulas. How can we prepare the reports? If you have any questions, feel free to write them in forum. Bye.